Dear friends, welcome back to my channel Understanding RS-GIS and Geography. In this video, I want to discuss about several important facts on Principal Component Analysis (PCA), which is a very popular statistical analysis for any kind of research and academic or other purposes. So let's start by several important facts on Principal Component Analysis, better to say PCA. PCA name is most well known than the Principal Component Analysis. Uh, Before starting the video, I want to request you please subscribe this channel and you can join my channel, and to get most important information and coding etc., please join my channel and you can give me thanks also. So let's start. Principal component analysis is a statistical technique which deals with only datasets not related to information of any, only independent variables, not dependent variables, in datasets with many interrelated variables. The one of the most benefit is it can overcome the multi-collinearity effects of datasets. So it is very useful for variables which are interrelated. Basically independent variables, not dependent variables, which are interrelated. And it is used to understand the variations within the datasets, not other information. Within the datasets, how much variations are there. And also it is used to reduce dimensionality and uncover dominant patterns. Dominant patterns of what? Dominant patterns of within the datasets, patterns in the dataset. It can uncover that dominant patterns, and the most useful this analysis is due to reduction of dimensionality. If you have 10 variables, there are some problems of analysis, but it can reduce the dimensionality of that datasets. So this PCA is used very largely throughout the academic area. Now we'll know how it can uncover the dominant patterns. By dominant patterns, you can understand the source like water pollution source etc. Think that if PC1 was dominated by nitrate, phosphate etc., which indicates agricultural runoff as a major pollution source. If you can see that these type of chemical are most abundant in the polluted water, then you can say the source of these pollutants are from the agricultural runoff. If you got that pattern from PC1, by knowing the variables of PC1, you can say that source of all these PC1 variables are same. It helps by identifying which variables explain the most variation within the datasets because it only understands the data. By PC1 and PC2, you can understand which are the principal components of variables of the dataset, and by the loadings of each variable within principal components, you can understand which variables how much responsible for the variations in the dataset. From the loadings of each variable within the principal components, means PC1 or PC2, you can understand which variables are the most responsible for the variations, not for any dependent variable. Everything in the principal component analysis is regarding on independent variables or responsible variables. So you can understand by the loadings of each variable from any principal components, principal component 1 or 2, you can understand which are the variables has the most responsibility on the variations in the principal components, variations in the dataset. Think that you got variable 1 loadings of 80% and variable 2 10%, then you can say that variable 1 is responsible for the variations of the dataset by 80%. And the next point is PCA, or principal component analysis, reveals latent processes, clusters, similar observations, and filters out noise, but it does not tell you which variables cause or predict an outcome like urban sprawl, etc. Okay, and now to identify the influential factors, what you need to do within the principal component analysis, you need to do some other things. To identify influential drivers, you need to follow principal component analysis with regression, machine learning, or spatial modeling that includes a dependent variables. As principal component analysis is for only the independent variables, to identify influential drivers on the dependent variable, not within the variations of the dataset, on the dependent variable, you need to follow principal component analysis with regression, machine learning, or spatial modeling, because those analysis took the dependent variables. But as you know, as I already told, that principal component analysis can't take the dependent variables. It can only identify the influence on the variations within the datasets. And then the next point is PCA can still serve as a powerful pre-processing step to simplify inputs and improve model performance. And by PCA, you can remove auto-correlated variables within independent variables as pre-processing step. It is easy to remove the auto-correlated variables from the analysis by principal component analysis process. If you have many correlated variables in your dataset, or you want to visualize data structure, then run PCA and then regression analysis to understand influential factors to any dependent variables. And ultimately it helps you understand the structure of the data, means it is all about the datasets. Now the principal component analysis plus predictive modeling like regression, machine learning models to identify the influence on the dependent variables. If you have run the principal component analysis to reduce dimensionality or remove the multi-collinearity of the variables, and think that I used PCA1, PC2 and PC3 as independent variable, then with dependent variable I used random forest model to know the important variable on the dependent variable, and I got PC2 as important factor. Then factor loadings of PC2 will be helpful. By the factor loadings of the PC2, think that there are 3 variable within the principal component 2, 5 variable within the principal component 2, and there have different loadings within the data sets. So by knowing the loadings, you can understand the influencing factors, how much influencing they are. Think that the principal component 2 is the important factor on the dependent variable. Then you can understand the loadings, and from the loadings you can conclude that variable 1 has the influence on dependent variable is more if the variable 1 has the more loadings. And this is all about some important facts on principal component analysis. I think this video will be very helpful for you, and please like this video, share among your friends, and of course comment me if you have any other facts or any other things on the principal component analysis, please don't hesitate to comment me. Thanks for watching till the end. Thank you so much.